Hi, welcome to part 7 of the video series about laws of motion. In the previous video, we have stated the universal law of gravity. Then, we have discussed how gravity is related to the difference of the mass and weight of an object. We saw the formulas related to the topic, but didn't manage to see them in practice. In this video, we are going to solve some examples related to the topic. First example is a multiple choice one. A satellite orbits a planet at a height where the gravitational force is 1/9 of the force it experiences on the surface of the planet. If the radius of the planet is r, the height of the satellite above the surface of the planet is a 9 times r, b 8 times r, c 3 times r, d 2 times r. According to the definition of universal law of gravity, gravitational force is inversely proportional with the square of distance between the centers of these objects. To decrease the force 9 times, distance must increase 3 times, as square of 3 is equal to 9. Especially in multiple choice questions like this one, learners happy to see that the answer is in the options and immediately mark C as the correct answer. We must be aware that answer of 3r we have calculated is the ratio showing us how many times the total distance has increased. But the question is to calculate the height above the surface. When the satellite is on the surface of the planet, the distance r1 is equal to the radius of the planet. When the satellite orbits around the planet, it is a distance h from the surface. So distance r2 is equal to the sum of radius of the planet and the height h. After substituting r1 and r2 in the first equation, radius of the planet plus height is equal to 3 times the radius of the planet. As a result, the height is equal to 2 times radius of the planet. So, the correct answer for this question is D. Let's see some more examples. We are asked to calculate the gravitational force applied on a 100 kg object by a hypothetical planet Z. Mass of the planet is 7.2 times 10 power to 20 kilograms, and the radius of the planet is 500 kilometers. Solutions for physics questions involving calculations must consist of 3 steps, as mark allocations are done accordingly. Usually, the first mark is allocated for the formula, the last mark is allocated for the answer. The rest of the marks are allocated for the substitutions. For all of the examples, we will try to follow the same structure. First, we write down the formula for the force of gravity. And then we do substitution. Universal gravitational force is 6 times 67 times 10 power to minus 11. Mass of the object is 100 kgs. Mass of the planet is 7.2 times 10 power to 20 kilograms. The radius of the planet is 500 kilometers, which has to be converted to meters. As an answer, weight of the object on planet Z is 19.21 newtons. In the second example, we are asked to calculate the gravitational acceleration on the surface of Jupiter. As we learned in the previous example, as a first step, we write down the formula. Gravitational acceleration is equal to universal gravitational constant multiplied by the mass of the planet divided by the square of the radius of the planet. Universal gravitational constant is 6.67 times 10 power to negative 11. Mass of Jupiter is 1898 times 10 power to 27. Radius of Jupiter is 71,492 kilometers, which has to be converted to meters by multiplying it by 1000. Gravitational acceleration on the surface of Jupiter is 24.79 meters per second square. In the last example of this video, we are going to calculate the mass for a hypothetical planet with gravitational acceleration of 4 meters per second square. We start the solution by typing the formula for gravitational acceleration, as its value is already given in the question. Value of gravitational acceleration is 4 meters per second square. Universal gravitation constant is 6.67 times 10 power to minus 11. And the radius of the planet is 600 kilometers, or 600 times 10 power to 3 meters. The only missing value in this equation is mass of the planet. After calculation, mass of the planet is equal to 2.16 times 10 power to 22 kilograms. In this video, we have solved some questions related to universal law of gravity. In the next video, we will continue with slightly difficult questions. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.